Welcome to the Energy breakout session. My name is Michael Ryan. I work with Science Foundation Ireland. We are the principal RD&I funder in Ireland. I'm also a national delegate to the ESFRI and a member of the ESFRI Executive Board. So the aim of the sessions in general is to explore the connection between research infrastructures and European initiatives, and indeed with industry. In our case, the energy sector, we will also aim to create an understanding of the available capacities of research infrastructures, including potentially for supporting testing, upscaling and deployment of already existing technologies and solutions, and also what capacities will be needed. So important topics, no doubt, particularly in what is becoming a rapidly developing energy crisis. So to do this, we originally had divided our session into two parts. The first part being dedicated to our panel members here, who I'll introduce presently, and the second part was over to you. We were going to have breakout tables, but I think, as you can see, it might be a bit of a challenge to create tables in a cinema-style, auditorium-style environment. So what I propose we are going to do is, after our panelists have given a brief presentation, we will also ask them a couple of questions. I will invite you as participants to provide comments or ask them questions directly. But I will also be introducing three key questions we feel which we were going to use on the round tables. And I would ask you to do a second thing, which is if you have any opinions or views on those three questions, to please share them. And my colleague from the Commission, Michaela, is going to be taking notes. So don't speak too fast, because apparently I've got to present this afterwards. So thank you very much. So. Firstly, like I said, we're going to hear from our four invited panelists there. So the questions, just so you know, at the end, that's sort of the overall view of the approach we want to take, is the current cooperative landscape with research infrastructures, all with an eye on energy, of course, identifying ways to utilise and best exploit research infrastructures, and finally, how we can optimise collaborative efforts, particularly between research infrastructures, technology infrastructures, and industry. So to our speakers. Our four speakers, and I will ask them to present and tell you who they are and what their job is. But from the European Commission, we have Pauline Sentis. We've got from Hydrogen Europe Research, we have Louis Mazurkiewicz here. We have Sverre Quale, representing ECCSEL. And from ESRF, we have Harald Reichert. So to begin, like I said, the presentations, if you could please come up here, introduce yourself, and then you can go into your, just to be aware, it's going to be approximately a 4-minute presentation with 3 slides from each of the representatives. Well, give or take a title slide, so 3 slides is what we're looking at. So Pauline, please, up to you if you'd like to come up here. Yeah. No. Do you want to come over here? Maybe if you want to take it here, it might be easier. If you can see your slides from there, yeah.
Okay, good afternoon. My name is Pauline Sentis. I am a policy officer in DG Research and Innovation of the European Commission, and I work in the unit for industrial research, innovation and investment agendas. So that's a long title to say that basically my team will look at what the industry does in terms of research and innovation to reach the targets of the Commission. So namely, at the moment, it's as you all know, it's the digital and green transition. And so that's why we have published the first ERA, so ERA for European Research Area, Industrial Technology Roadmap for Low Carbon Technologies in Energy-Intensive Industries. So it's the objective of that roadmap is to look at the technologies that are currently relevant to reach the decarbonization targets for 2030 and 2050, and what the industry does to deploy those technologies so that they are in place in order for them to actually diminish their greenhouse gas emissions. So this roadmap goes over a lot of aspects. So we look into the technologies, the investments in these technologies, or the approximations that we can do, also the patenting around it, and all the framework conditions to enable them to enable that research, innovation, and uptake and deployment of those technologies. It was published in April, and it is available online if you want to have a look. Okay, next. How can I?
Next slide, please.
Okay.
Oh, yeah,
yeah, so one of the findings of the roadmap is about like the research and innovation investment needs that are absolutely massive and that are currently not matched by what is being done at the moment. So under the current conditions, we are not to meet the 2030, 2050 targets. And the most important investments have to be on the deployment part. So really the last milestone after the technology has been developed, how to really deploy it and have these first-of-a-kind installations and demonstrations. Next slide. So based on these findings and others, we've developed a list of actions that we are trying to implement with available instruments at the Commission. So we work with like the other DGs, and so I'm not going to go over all of them, but basically I think the most important is to establish what here we call it an industrial alliance, but it's most probably going to be something similar, such as another type of initiative, an investment pipeline to really make the investment from the industry side really like reach the needs and match the gap. Okay, next slide, please. So that roadmap, that was we finished drafting it before the Russian invasion of Ukraine. And then, of course, a lot of things have changed also at EU level. Things that were, I mean, the energy crisis has come to aggravate the already like problem with the decarbonization. So at the same time, it is a challenge because it makes it even more like urgent to really like to take independence from fossil fuel, but then it's also, I mean, now we have another good reason to really do it, because in order to really like break ties with Russian fuel imports. So there has been this initiative, Repower EU, that I think you have heard of, with like a lot of measures in order to take really like this distance from Russian fossil fuel in order to really cut ties like by in a few years. Before that, there was already the Fit for 55 package. So all these initiatives going towards cleaner energy. We also have the Hydrogen Alliance, the EU Solar Energy Strategy, just to name a few. Then when it comes to more specifically low carbon industries, of course it has a lot to do with clean energy, but not only. And then for that, I think you all know the Horizon Europe Framework Program that funds a lot of research projects towards like cleaning energy and like having low carbon technologies being developed and deployed, especially through the Clean Steel and Processes for Planet partnerships. So that's the link between the Commission and the industry. And then, yeah, also to mention the emission trading system, that the budget of which goes into the innovation fund, that's also there to fund decarbonization research projects. So that's just a little overview. I don't know all the things about like what the Commission does for clean energy, but I'm happy to hear your questions.
Thank you very much, Pauline. So what we'll do is get all the four speakers up to give their presentation, and then obviously we'll ask a few questions, then we'll go straight in. So if I could ask Louis to come up, please.
Hi, thank you, Michael. Good afternoon, everybody. So I'm Louis Mazurkiewicz from Hydrogen Europe Research. Basically, so Hydrogen Research, we are the European association representing universities and research and technology organizations active in hydrogen and fuel cell technologies. So if you go to the next slide, This is a brief presentation in a nutshell of who we are. We have 122 members, more or less split 50-50 between universities and RTOs. And these 122 members are spread out across 27 countries, mainly in the EU, but we do have an associate country member in Morocco. And within our activities, we have over 500 active researchers that are active within what we do at Hydrogen Europe Research. So basically our vision is to support research, high-level research on hydrogen and fuel cell technologies in Europe and support the hydrogen industrial ecosystem. And for this, we base this vision on 4 pillars. The first one being, as I said, research, high-level research, make sure that lower TRL but also higher TRL research is efficiently undertaken. We also support the development of research and technology infrastructures, as they are very important to upscale and uptake the hydrogen technologies that are needed today but also in the future. We also advocate for sustainable development, making sure that the hydrogen technologies that will be developed are indeed sustainable. And for this, we push to have a sound and scientific approach and methodology to calculate the carbon footprint of the hydrogen technologies. And finally, we also have a stronger education component because in the future there will be the need to have a trained workforce working in the hydrogen sector, and therefore we also work on academic, vocational and professional trainings within our skills working group. If you go to the next slide, our main activity is the participation to the Clean Hydrogen Partnership. So the Clean Hydrogen Partnership is the successor of the previous 2 partnerships on hydrogen and fuel cells, which were the Fuel Cells and Hydrogen Joint Undertakings 1 and 2. And these partnerships have been renewed into the Clean Hydrogen Partnership that will be funded at least with 1 billion euros of EU funding from the period of 2021 to 2027. We are one of the participants to this partnership alongside the European Commission, represented by DG ENER, DG MOVE and DG RTD, but also with our industrial alter ego, Hydrogen Europe. We have a strategic research and innovation agenda for this partnership, which outlines all the research and innovation activities which are forecasted to be covered over the partnership. And our main activity within this partnership, basically our day-to-day, is that with our members and with the members of Hydrogen Europe Research, in collaboration with the Commission, we participate to the identification of annual priorities and to the drafting of the research topics that are going to be included in the annual call for proposals. So I don't know if you've seen, but in 2022 there was a first call which was launched in March, and with a funding of 300 million for research and innovation topics, with 2 deadline. The first one passed and the second is in 1 week. So there will be roughly 40 research and innovation topics that will be funded by the EU and will start as of next year. If you go to the next slide, in other activities, which is maybe interesting as well for the ESFRI, is that we have undertaken internally 2 mappings. The first one on the research activities that our members undertake within their organizations, and the second one on the research and technology infrastructures that are available within our membership. And it seems this is something that's not really available at the ESFRI in terms of infrastructures really for energy, and in this case specifically to the hydrogen sector. So this tool hopefully could be, first of all, important for our members for them to gain extra intelligence and also harness collaborations, but also in all the discussions we may have with other stakeholders, with the Commission, within the Clean Hydrogen Partnership, or within the EU ecosystem. So you can see a little snippet of our research activities mapping. It's just a short. Two small pictures of what it looks like, and basically using the filters you can see which organization is active on which technology, which systems, subsystems, subcomponents in Europe. And just to cap off, as time is up, we also have 2 activities, but other activities we undertake at Hydrogen Europe Research, but I'm not going to go into too much detail. We also have a policy working group where we reflect with our members on the different legislative proposals relevant to the hydrogen sector and the hydrogen research community, to answer to different consultations, but also to draft position papers. And we, as I mentioned earlier on, have a skills working group which reflects on globally, what education tools and educational courses can be put in place to upskill, reskill, and educate people in the EU. So thank you very much.
Thank you, Louis. So Sverre, if we can hear from ECCSEL, please. Thank you.
Yeah, thank you for being invited to present ECCSEL and to the panel debate afterwards. ECCSEL was established just a bit more than 5 years ago, and the founding members were Norway, where the operation center is located, and France, Italy, United Kingdom, and the Netherlands are partners. And we provide more than 20 facility owners provide up to 90 and even more than 90. We are expanding with new facilities continuously. So come back to that we also are trying to recruit new member states, but that I will bring up in the panel debate. As you can see, it's different kinds of facilities. It's small, lab scale, it's medium size, and we also are joining forces with industry on larger test facilities. So we are covering the whole scale basically after 5 years in operation now. So we are distributed across these 5 countries. And obviously the vision is that we should contribute to reduce CO2 emissions according to the targets that has been established, both on a global level but also European level. So next, please. There, yeah. Just to show you a timeline, we were established back before 2008, actually, and we came on the ESFRI roadmap in 2008, and then we became a landmark in 10 years after that, and established as an ERIC in 2017, after being funding in the preparatory phase by EU. And before we became a landmark and ERIC, we already have started investing into the infrastructure. So in addition to the already integration of the existing facilities back in 2015, we now have invested some 100 million euros, but still plans to invest 100 more millions up until 2030. So basically most of this has been national funding, public funding. And above the timeline, you can see the funding that we have by the membership fees of the 5 countries, which covers the basic administration and management. And then on the top of that, you can see all the EU project funded. We have after we became an ERIC. So the biggest project is the Infrared 3 project, the Accelerate, which is ongoing. And I will come back to that on the next slide. And then we have several projects where we are partners, and we are working together with other ERICs and also industry. And the yellow ones, or maybe green ones here, light green ones, is within energy. And we have participated in several proposals on the top there, and are going to do that not only in the Pillar 1, the dedicated for infrastructure like us, but also in the thematic areas together with industry. So we are funded, in addition to the basic funding from the partners, we have additional funding from EU through all these projects. So next slide, please. So the last one, I just want to visualize something we have been working on within the Accelerate project. And we have mapped the research gap or technology gaps together with industry and the scientific community. several workshops with different kind of industry we have had and get input to which are both the short-term but also the longer-term gaps that we see. So we have then developed what we call research priorities and then a development plan for investments, future investments into our infrastructure. So this is the basis for now the future investments. Obviously, it will be adjusted as we go along because the environment is changing. The energy crisis, not to forget that, also will have an impact on our priorities into the future, which we'll also come back to later. So I think I'll stop with that. It's a short presentation. Thank you.
Perfect. Thank you very much for a very concise. Harald, please. ESRF. Thank you.
So it's my pleasure to show you a little bit what we are doing. We're a classical large-scale research infrastructure, the European synchrotron radiation facility. It was a groundbreaking instrument when it was built more than 30 years ago. It was the world's first third-generation synchrotron. It's funded by 21 countries. It's not funded by EU. These are member countries. It's an international organization. And as such, the ESRF is a member of the so-called EIRO Forum, where the other large European research institutions are assembled. So this is CERN, ESO, ESA, ILL, and a few others. It's 8 members. ESRF is one of them. And we have a budget of about 100 million, and I'll come to that in a moment, why this is going to be one of my points here. And we've just finished an upgrade where we produced the world's first 4th generation high-energy light source. The reason why I'm mentioning this is, and this in conjunction with the budget. Now, when you have a research infrastructure like that one, you build it for decades. Right? A lifetime of an instrument like that is typically 30 to 40 years. So whatever you build has impact decades into the future. So when we actually did the upgrade from a 3rd generation machine to a 4th generation machine, one of the big issues that we already identified in 2013 was that we are actually part of the energy problem because we are sucking up huge amount of energy in these large-scale facilities, accelerators, and other machines that we operate for a long time. So we are actually, on the one hand side, part of the problem. So we have to take care of that and reduce our own energy footprint, and that's what we did. We reduced it by 30%, the energy uptake, while at the same time increasing the performance by a factor of 100. Right? But you have to think in decades. Yeah? So this is nothing you can say that I'll do it in 3 years. You have to rebuild the facility for that. And this is a major investment, which you do once every, let's say, 30 years or so. Yeah? Can we go to the next one? So these kind of instruments, they are not single purpose. Can you switch the slide? Nobody there? So these kind of instruments, I like to call them Swiss Army knives for science. And the reason is that we are actually a tool that can be used in any kind of natural science or technology application, if you want. So we are very busy in the health industry, for instance. A large part of drug development is done at facilities like the ESRF. There's a lot of others that do the same. Materials development, the energy problem, of course. Energy problem in the sense that we are actually helping scientists to develop tools to deal with the energy problem. And that's the second part where we have to come in as part of the solution. So part of the solution is reduce our own footprint. But as I said, this goes in decades. And the other one is helping others to come up with new technologies to actually do that. So this is, if you look at the ESRF and the entire scheme, about 7% of our research is only on energy storage materials, if you want, and systems, like battery research and things like that. That's about 77% with, can you please go to the next slide? Nope, that was back. Forward, yeah. So this is how a machine like this looks like. We have 45 instruments that we run in parallel, which means at any time, given time, you have about 50 research groups working there and producing results with a variety of techniques. Can you press the button once more? And to give you an overview of the scale, we have about 10,000 user visits each year by roughly 5,000 individuals. We do 2,000 experiments, and we have about almost 2,000 publications, so it's a massive operation. So if you take the number that I showed you before, it's about 100 experiments that deliver results that are getting published each year just on energy storage materials. So this is really a large contribution that we give in this area alone. There's lots of other things. I showed you chemistry. Chemistry is, for instance, mostly development of catalysts. Why do you develop catalysts? To reduce the energy uptake when you actually produce materials. That's one of the main functions of catalysts, right? So if you actually put the energy problem in a bit of a wider context, it's more than just producing energy you use and store it, but it's also the way you use it, right? So, and all of these things are in the remit of this kind of facilities, and you have about 15 of those in Europe. The ESRF is the largest one, but there's a lot of other facilities that have similar operation parameters. Can you go to the last slide? So now I'll use this one here to demonstrate you where we are today and what our problems are, because we were also asked not just to show what we do. The goal of this meeting is to actually see where we could do better. And I use that slide to explain that in the energy sector. So if you look at what I'm showing here, this is actually the full cycle. You start on the left-hand side with materials development from the atomic scale. You actually tailor materials for a certain property and performance. Then you take these materials, you put them into an assembly, and the next thing you have to see, how does that assembly perform? So these are typical experiments that you can do at facilities that we operate. So you can, for instance, cycle batteries thousands of times and actually watch how they degrade or not. Hopefully they don't. And in the end, if you go full scale on the right-hand side, we actually have the power to put real devices in the beam and look at the device scale as they're being used. So this is actually a battery. If you go on, all the way on the left-hand side, this is something that has a project that has been going on for 6 or 7 years, driven by NASA and some other partners, to develop the world's first battery where you can take a hammer and a nail and actually hammer the nail through the battery, and it's not losing its performance. It's not dying. It's the first battery in the world that does that. It took 7 years to do that. So that gives you the scale at which we do these experiments. So I call them heroic experiments. And one of the goals or challenges that we face is to actually, and one of our other panelists from before knows that because I did this in a large meeting 2 days ago, is to democratize this. Because these are individuals who are experts who know how to do these things through the entire chain, right? So how do we manage to bring this to the field so that somebody who doesn't know the details of all of that or doesn't know how to build an assembly like the one you see on the left-hand side, yeah? Or right-hand side, how do we make sure that people can actually use that? And the last problem I would like to mention is also on the left-hand side. The experiments that actually led to that produce an incredible amount of data, and we are actually producing the first instruments now that produce a petabyte of data per day, which is CERN-like data rates with a budget that's about 5% of CERN. And you can imagine that this is a big problem for us. So we are actually looking for active collaboration with other infrastructures, and we had several members this morning from PRACE, EOSC, and so on, to actually help us with this, because today they're in silos. They're not working with us, and they're not helping us. So we would actually have to solve all of this by ourselves to make this useful to, let's say, a broader audience, not just a few specialists who know how to do that. And this is, I think, where another challenge lies, especially with the people and the groups that are assembled here, particularly, because I think we're still too much in our silos, and we do not have solutions that go across these silos. So with this, I'll finish.
Thank you very much. Can you hear me? Oh yeah, there we go. Thank you very much, Harald, indeed. And it's something no doubt we'll come on about later, because we did discuss it this morning about this siloed approach, whether it's intentional or otherwise. What I'd like to do is just go in a couple of questions for the panel myself, and I'm going to hand over to the floor. In the meantime, could I please ask ask you to put on the questions slide up there as well, which is something that I mentioned before. I'd just like you to reflect on these questions, please, as an audience, and if you have any responses or opinions to them. Just to begin, Louis, if I can start with you. We heard from Pauline earlier referencing Repower EU, for example, as a response to the Russian invasion of Ukraine. What role can research infrastructures play in the uptake of hydrogen technologies?
Hi, can you hear me? Well, obviously you know that today we face a climate crisis as well as an energy crisis. And for this, hydrogen has been recognized as one of the energy vectors that can decarbonize some sectors. So this is an important energy vector on one side to decarbonize, but also reduce our dependency on fossil fuels from certain foreign countries, notably Russia. And for this, we need a lot of hydrogen production, a means to store, distribute and transport this hydrogen, but also then use it. And for this, currently we don't have the capacity to do this. There's still need for upscaling and uptaking. And without research infrastructures to focus on the lower TRL technologies that will need to be developed to increase the performances, but also increase the sustainability of current hydrogen technologies for the future, and technology infrastructures to test the current technologies in the right operating conditions, in the right environments, so that they can be used as soon as possible. We won't manage to achieve the objectives, especially as we need 10 million tons of hydrogen to be produced within the EU by the end of the decade. Also importing some hydrogen from abroad. We absolutely need efficient means to test and develop these technologies, and without research infrastructures and without technology infrastructures as well, without sufficient funding and support for those, it will be very tough to achieve our goals, or achieve the European goals.
Thanks, Louis. And I think as well, aside from just collaborating with research infrastructures, it's really needing to take that multidisciplinary approach, I think, as you said, because it touches on so many different domains of science and engineering. Harold, if I can come to you, we've talked before, I think there are, correct me if I'm wrong, 16 to 18 other light sources around Europe. The combined energy needs must be just astronomical for each of them, given the energy crisis, the rapidly escalating energy crisis. However, those light sources, of course, can arguably be, if I heard you correctly, a saviour to our energy crisis at the moment, if dealt with in the right way. Could you perhaps explain to us ways in which energy research infrastructures or research infrastructures collaborates with industry to sort of help both, I suppose, be able to address their demands, but also to be able to collaborate to really the most pressing issues that we see today at the moment in Europe?
Yeah, one of the problems is that we're not doing nearly enough when it comes to working with industry. And the reason is what I mentioned before. These are typically very involved experiments. If you look at some of these things like materials development or the things I showed, this development of this battery. Now, if you would like industry to buy into that, you actually have to provide a solution. And the solution starts already when you have to translate the problem they have into an experiment, because in the end we do experiments, right? Now, as a facility, we are in a unique position. I showed you that we have about 10,000 people a year stopping by at our facility, submitting 2,000 proposals. So we're essentially a research hub, like an Amazon if you want, and we're the only ones who have the knowledge who in the community does what and knows what. This is what I call domain knowledge, right? Because this is in our databases. Nobody else has this information. So if we have someone from industry coming saying, I have a problem, can you help me solve it? We actually have the knowledge to bring them together with the right people who actually know how to do it. Because we as a facility or research infrastructure, we don't have enough scientists to cover everything that I've shown there, right? But we know who can. Then you have to take that problem and convert it into an experiment. That needs specialists. Not the typical people who work today on those instruments, because they are used to work with academics who know exactly what they do. And they switch every 2 days. So they have no time to do that for them. So this needs so to say, an ecosystem by itself to do that. And then comes the data problem. Because what we are used to in these large-scale research infrastructures, there will be experimenters, be it industry or academic. They come, and sometimes after 2 days, they walk away with hundreds of terabytes of data. And they have nowhere near the capacity or the knowledge to deal with it. So they have data, but they don't have an answer. So again, we have to build an ecosystem. We call it a data-based solution ecosystem, right? That starts from translating the problem into an experiment that an RI can deal with, together with the experts it can actually pull from, and then help to provide or give an answer, not just data.
Harald, if I could just bring this on a tiny bit further. In Ireland, in our funding agency, our remit was expanded. It was just basic research. And our remit was expanded to fund applied research. And of course, we had the community up in arms saying, you're not funding any fundamental research, you're only focusing on applied research. So we did a survey with industry and said, is there a value of funding or supporting basic research for the industry partner? And it was a resounding absolutely from industry. Basic research is crucial. The reason why I'm asking this question is you touched on it in the battery technology. It has to start somewhere. In your view, very, very briefly, so I can move on, is there a role for that basic research, all the way up to applied research? Now, I don't want to use this term TRL. I have a problem with that, so I'm not going to use it. But is there a role for that basic research where industry is effectively a user and a potential I suppose, customer for this?
Absolutely. Most of the research that we do with the industrial world, if you want, and we have several hundred customers at the ESRF, is actually published. That is in the lower TRL levels. In the higher ones, of course, they don't publish when it gets to the products. But most of it, actually more than half of it, gets published in peer-reviewed literature. So this is real research. Real results that are appreciated by the academic community just as well. And they collaborate with academics for that.
Great, thank you, Harald. I'm just going to move on briefly. Sverre, in your view, can research infrastructures contribute, how can they contribute to the Paris and EU climate goals despite the escalating energy crisis?
Yeah, despite the energy crisis, I mean, if you look at the picture now, you have to prolong, at least they tell, the politicians say that you have to prolong the fossil fuel production, even talking about exploring more oil and gas fields, which may be coming to operation 10, 15 years from now. Everything to compensate for missing or the energy prices going up and the lack of energy. So how do you do that without emitting even more CO2? You have to implement the technology. Talking about hydrogen, for example, I mean, blue hydrogen is being discussed. I think that is one thing we have to look at, implementing technology to actually convert the natural gas, for example, into hydrogen and store the CO2. That's one thing you have to do. And we have been discussing this with the industry, and industry is this is quite new for them. So they're coming to us to ask, do you have technologies available which is mature enough to implement tomorrow? And we say, some, yeah, but it's very costly. So they can't afford it with the CO2 prices, which are all the taxes today. So there are several things we have to look at and where we can contribute here.
Thank you, Sverre. Just I'll pass over just to Pauline, if I may. We heard earlier today about silos, research infrastructures in silos, and need for promoting the, I think it was the Ferrari in the garage example. Pauline, just sort of with an eye on that, do you feel research infrastructures, what role can they play in bridging the gap between investment needs and actually what is being planned? Think of public engagement, outreach as well as this, please.
Yeah. So that's a good question, actually, because like in the roadmap that I was presenting earlier, as I was saying, we were focusing on our let's say our actions focus on like the really deployment and first of a kind of the higher TRL technologies, because that's what is most needed for the, reaching the 2030 decarbonization targets. So that's sort of like my focus at the moment. But we also do not lose sight of the longer term targets. And for that, the development of lower TRL technologies is absolutely crucial. And this is where research infrastructures play a significant role. And I was also, I'm also here also with questions, and I'm wondering to what extent so research infrastructures can also play a role in maybe medium, higher TRL somehow. But then if we keep it to the lower TRL by maybe identifying what are the most efficient and the technologies of the future that will be needed for the decarbonization targets, in particular 2050. So yeah, that's how I see where the research infrastructures can play a role in the roadmap implementation.
Yeah, okay, thank you, Pauline. Now I'd like to hand it over to the audience. Is there any comments? Please, Daniel.
Yeah, thank you very much. 2 comments to the very nice talk from Harald Reichert. As always, ESRF is a showcase. And to the second question, how can the use of existing RIs be increased? I would say at least I have part of an answer, and you know that. In a small country like Austria, there's only one division, so the privilege for me is that I have an overlook over many research infrastructures. And what I see as a good practice is, I come back to ESO, all these research infrastructures should change from expert mode to data or to a mode everyone can use. This is really hard to do, but there are already models for that. If you are using ESO and you're an astronomer, okay, you're an expert, but the instruments are in the meantime are so difficult you cannot be the master of this instrument. So ESO is building software, and they name it pipelines. At the end of the day, the user gets a data set which he can use immediately, and he must not be an expert of all the machine details, and that's the case for sure also in ESRF. So one of the most important things is to broaden the use, is to provide solutions and not just to provide the data, the raw data. And I think in astronomy that works, it should be work also in other examples. And the other thing regarding energy, this will, until now, we saw energy just as a budget line in the cost of the research infrastructure, more or less. Yeah? In future, this will change, and it will also be that the member states or the shareholders will also have to think about, if it's an energy intensive research infrastructure, what's the best, how can we buy this energy or produce it? That was until now not the question. And in future, I don't think that hydrogen is for ESRF the best use case, but you are in the middle of 2 rivers. So why not have a long-term investment in a hydropower station to provide you with electricity you need, and you need a large amount. Until now, we never thought about that. You just had the idea and got it. You said the power system.
Actually, there is one 5 kilometers down the river.
Okay,
but it's not ours. It's the cities.
It's the cities. Yeah, but why not think about such things?
No, it's already there. We can't build another one. You can't have one every 5 kilometers.
Not, but every 10. No, just an idea that we have to think in bigger ideas.
Thank you. Any other comments? Please, Louis, Jose Louis. One moment. I'll do double jobs. I hope I'm fit enough now to move around the room at pace.
First, like a comment, I was a little surprised about the title of this panel and the presentation, but okay, because for me energy is mostly about, especially with the challenge we have, is to produce energy, a new method to produce energy, and of course later take care. I only can tell you that I was in July in United States, working around different national laboratories in DOE, and I was surprised how much is invested in United States in nuclear energy development, new reactor, small modular reactor, advanced nuclear modular reactor, and in fusion. Also, I know because there was discussion about how China is investing 50% of big budget in fusion and fission. Russia is investing big budget in fission, much later in fusion. And this is why, because we have challenge. Apparently, following the newspaper in my country, in 2030, will be forbidden, probably the internal combustion motor engines, and we need a solution for 2030, not for 2300, no, for 2030. So this is the situation. So United States is facing this investment to make money, China for geopolitical influence, and Russia the same. Europe, this is one of my questions, where is investing Europe, like Commission, for energy production? To my knowledge, it's only fusion, and not much, or very slowly. And second question, just a very particular question about this carbon capture. Can you tell me the figure that I can really understand? How many tons of carbon capture can be done today? How will be the scale for industrial scale for, let's say, 5 years? And just to have a comparison for me, how much is the production of CO2 tons or one of the industries, for instance, stainless steel industry or fertilizer industry, in order to have an idea? Thank you.
Anybody want to take the question, Sverre?
Yeah, I can take the last one. I mean, in Norway we have experience with storing CO2 for more than 20 years at the Sleipner oil and gas field in the northern part of the Sea of Norway, in the Barents Sea. No, not that's Snowat. Actually, two fields which are storing CO2. And you talk about megatons, and it's really the experience there is that this is possible, and not only possible, it is practical if you do it from day one. If you don't implement the technology after you have the installation in place and production, then it's too expensive. But you have to think early on and to implement it, and then you have the technology. The challenge is that you don't have explored or acceptance for storing onshore the CO2. That's for Germany, for example, nowhere you are allowed to store CO2. So what the concrete project now is in the North Sea. It's north offshore of Denmark. It's also looking into the Mediterranean Sea. So it's offshore. And you need to not only 1 or 2 megatons, you talk about 100,000 times that, you need to contribute, to have a real contribution. But it's not impossible. You have to do research on all levels, but the technology is available for capture, partly also for utilization of CO2, converting CO2 to products, to chemicals, for example. The industry is looking very into, I mean, the energy, the industry which is using a lot of energy. You need to implement this technology, because otherwise you will have to release CO2. This energy is without any other solutions. I mean, hydrogen is a solution combined with, for example, natural gas or green hydrogen from renewables, absolutely, but it's not going fast enough. You need CO2 or capture and utilization technology.
Thank you, Sverre. Thank you. Okay, we'll move on to next.
Maybe if I can just add just a
very briefly,
point.
Louis, yep.
Yeah, very briefly. Regarding, I heard hydrogen receiving funding. Indeed, even yesterday, there was an announcement of the Hydrogen Bank, which would be receive 3 billion euros, maybe upscaled to 20 billion euros, in order to kickstart, let's say, well, upscale the hydrogen industry, get to the 10 million tons required by Repower EU. So indeed, the hydrogen sector is getting quite a lot of support. But yeah, obviously then it's, I suppose that the situation between the US and the EU is different because there are different entities. One's a federal state, the other's a European Union. So the energy funding obviously depends on the countries here in Europe. So I can't really comment on that. But at least hydrogen is receiving some support, if that was a question that you had as well.
Thanks, Louis. If you could please introduce yourself.
I'm Nadia Vitsaniova from Eli Eric, which means we are dealing with lasers. But one part of my life, I was in the European Energy Research Alliance and working for an energy research organization, housing reactors and fusion research infrastructure. So I am very much in line with my colleague in the line here. But I was in Trondheim once, and I am really happy that you prosper. But my question is, when you have a research infrastructure, could you give us an example how you are connected to a technology research infrastructure? Because to my opinion, many research infrastructures are in one part of their capacity able to be technology infrastructures. This is a question for Sverre, Quale, and for the gentleman from hydrogen. And of course, could you give an example of such a relationship for ESRF? And I am really happy that you showed us how you interact on material research, then on material degradation and on resistance of products to radiation, and etc. Please, so could you give us a concrete example of a relationship between your research infrastructure and a technology research and a technology infrastructure? Thank you.
Yeah, we are working with CEA because they are local. They have a big site in Grenoble, and of course we work with organizations like Fraunhofer. So we have plenty of contacts, but nothing, let's say, really institutionalized. They use us a lot, but it's not institutionalized, if you want.
Great, thank you. Just very briefly, Sverre.
Yeah, briefly on the technology infrastructure and ourselves. We have actually delivered 2 EU proposals where we have joined forces with steel industry, with the process industry on constructing a test facility which will be actually attached directly to a cement plant, for example. And unfortunately, we didn't succeed in, but we have high scores, so hopefully next call we will succeed. And then this large-scale test facility with CO2 directly from the plant will be part of ECCSEL. So that's one concrete example.
They've been submitted, yeah? Proposals submitted, yeah?
Yeah, it was a bit this, but regrettably we didn't succeed. We had high scores, but probably somebody had won that. But similar calls will come up. So.
Okay, that's good to hear. Okay, recycled proposal. Louis, quick response, please.
I'm not going to add much to what has been said. Just yet to say that in the hydrogen sector as well, within our members, we often have members who both have infrastructures, have the characteristics of research and technology infrastructures. They do have a wide range, operation range, which is very interesting. And then also there is cooperation between different RTOs in setting. They try to set common infrastructures, open infrastructures in different areas of the EU, which could be accessible by different stakeholders. They're often called open technology platforms, open innovation test beds. So this is something that is discussed quite often in the research community in the hydrogen sector.
So I'm Alan Weeks. I'm also from the extreme right infrastructure, so sorry about the domination on that. I have a question for Harald, but I think it's also relevant for the other participants. Access to ESRF is open and excellence-based, and now we're dealing with a kind of mission-based challenge. I mean, has it been talked about? Is it something that could be useful to have kind of specialized calls and campaigns focused, like we saw with COVID, focused on these kind of areas and with specific funding from the Commission to support that?
That's precisely what's underway, and I call this a change in the business case. We have been operating in the past, as you say, on an excellence-based. You write a proposal, it's people check, it's merit, it's peer-reviewed, and if you are successful, you get the beam time. There is no program behind it. And this is something that we're changing now, not only at the ESRF, but at other facilities as well. And for the one where I will work next, this is actually the main mission of the new machine that we're building. So we've been operating the same business model ever since we have these machines. So it's the first time that we completely rethink the business model. It will be built exactly on what you say, challenge-driven, instead of just isolated projects like these heroic experiments that I showed.
Pauline, would you like to add anything further onto this point about Alan's question in relation to opportunities available from the Commission's perspective?
Yeah, so as I said, there is there are lots of funds from the Commission for research. So the Horizon Europe has like a very, very large budget available for projects that fit in one of the priorities. And then there is also the innovation fund funded by the emission trading system. So that's another budget. So there is budget on the table for research. But then as Louis said, it's the EU is not a country, and there are also all the member states within the EU that have, for most of them, also dedicated quite high budget dedicated for research and for research into energy. So that's just a complement that the EU is providing. And also I think the biggest added value from the EU is, of course, to put all the research facilities and industries and universities around the EU together, which makes everything much more efficient than going further.
Research. Thank you. Thank you very much. Yeah.
Okay, Rob McGreevy representing the League of Advanced European Neutron Sources. A couple of quick points. Over the last years, we've got used to not only understanding the financial cost of research infrastructures, but also working on the economic impact of those. You've talked about the energy or the environmental cost being worked on. We also have to work on how we represent the environmental benefit of those, because otherwise the easiest way to have a zero carbon footprint is to close, right? But then you lose all the benefits. Secondly, in terms of the scale of the data challenge, and Harald has mentioned the data challenge there, this is something I'm working on at the moment in the UK. The scale of the data challenge facilities like this is actually a research infrastructure of the scale of the ESRF. Not exactly the same scale, but still what you're talking about is several hundred people being needed to provide the services that deal with all that data. It's not 5 postdocs. And we've got, if we will not deal with that unless we understand it's a big thing.
Thank you. Unless it's very pressing, we'll move on. If you would like to respond very briefly, Harald.
Very briefly, we know that, and we can solve this not by each facility asking for hundreds of people to solve it for its own, but create a network where all the facilities actually use the same network of, or let's say, infrastructure, so that you don't have to do it all over. And then it breaks down to, if you have 20 facilities, to not too many bodies per facility.
I'm Philip Drobinski. I'm a climate scientist, and I'm also the head of an interdisciplinary center called Energy for Climate. And so I would like to just jump on this cooperation with ARISE. It's not only energy infrastructure that should, let's say, cooperate, but also there are really strong issues relating directly environment, climate, and energy that should be addressed in joint approach. And I think ARISE are really the good tool for that. So I have, let's say, 3 issues that I see, but there are more. It's outdoor characterization of energy system. We know that, for example, PV panels do not behave as they are expected when they are put in the field. So we need geophysicists, we need material engineer science, we need also data scientists to monitor, to develop models of behavior. In the field of CCUS, there are more and more innovation in the field in extracting CO2 directly or in the ocean so that it indirectly remove it from the atmosphere. But assessing exactly the amount of CO2 which is removed from the atmosphere through these devices totally at its early stage, and we need infrastructure to do that, monitoring experiments. And the last point is the assessment of environmental impacts of energy system, which there again, there is no well, there are a few studies, but no robust methodology and no norms that could help assessing really the actual impacts, environmental and even social impacts of energy system. And I think for at least these issues, and there are more, we need more cooperation between the 4 groups.
Thank you very much for that commentary. Thank you.
Good afternoon. My name is Fabio Taucher. I'm working for the Scientific Development Unit of the Joint Research Center. And I would like to maybe address the second question on good practices. And I would like to refer also to the presentation made by Pauline on the ERA technology roadmaps. And there we're contributing on how standardization can be used as a vehicle to valorize research innovation, then closer to industry, closer to the market. So in this sense, I would like to stress that it's very important that in the use of the research infrastructures by industry, but also by researchers, that we address what is called pre-normative research, because pre-normative research is what will enable our results from research to go to higher TRL levels, technology readiness levels. And I can give an example. In 2000, I believe it was 2016, we had a workshop organized by the GRC with European stakeholders called Power to Hydrogen, where the idea was to mix hydrogen with enriched gas in the pipelines of our gas network in order to conduct hydrogen through our gas pipelines. And from this workshop, where we involved researchers, industry, and also those that are drafting norms, we're able then to come to concrete results on how to achieve that. But you cannot get these results if you don't involve a research infrastructure or a technology infrastructure. So my recommendation is to also address pre-normative research in the work we do in the RIs in collaboration with the TIs and SMEs and industry.
Thank you very much, and it's something that we're going to be looking at as well within the ESFRI, indeed, that exact question as well. Not only cooperation between RIs and TIs, but also cooperation with industry, and I think that's a crucial element, as we discussed. I'm just going to bring it over, this gentleman over here, and then Harald. Thank you.
Thank you. My name is Arne Jungstand. I'm working with the accelerator in Darmstadt with a facility for anti-proton and ion research, but I'm also used as an evaluator for other research infrastructures and for fusion for energy. And that leads to my question. Fusion for energy, of course, is not a research infrastructure, but they are doing a lot of research for fusion. Fusion, in my view, is a little bit missing in this discussion until now, as other countries, and it was mentioned before, are doing a lot in this. And not only the big things like ITER or other things, also looking for the small variants and small things there. And the question for me is how the existing energy network, which already exists in this field of energy, collaborates and with the people doing research in fusion energy.
Thank you. Any takers? Or indeed, does anybody want the floor answer that question?
Well, I can take that one. We have people from fusion researchers to come and develop materials, like we do for batteries, for the fusion reactor walls itself and things like that. So they actually do concrete research, yes.
Just before, do you want to answer this? Yeah, I can comment. Right, please, thank you. And then we'll move on to question over here.
So, I mean, one of the alternative approaches to fusion, other than magnetic fusion that we see at ITER, is laser-based fusion. There's been a lot of success with that in the last 2 years in the US. At Eli, we are also have lasers optimized for that kind of research. I do think, though, the funding stream for nuclear research is different. I mean, it doesn't go through Horizon Europe the same way that the other research does. And I think there's a disconnect there, simply. I mean,
yeah, absolutely. So we want to stay on this point for a moment. To do at this point? Yes, great, thank you.
Taina Kurkisonio from Aalto University, Finland, and also from the energy, SWG. The fusion has been mentioned so many times, and I'm a fusion researcher. So I would say that Europe is not doing bad, but Europe is not as good in marketing and advertising their work. So for instance, MIT with the Spark, they claim that they can do these small modular, not necessarily modular fusion reactors. Well, there is a company in England who has been doing it for years now. It's just that we don't make as much noise.
Thank you very much. One more, please.
My name is Paolo Cunzo. I'm working, I am the Italian ILO Industrial Zone Officer for Fusion for Energy in ITER, and I'm working in Enea. I would like just to stress this point about the fusion. It's really important, I agree with them. But I would like just also to stress another point that would be, another aspect that would be really important. To fusion, the fusion domain, there is also a big community of enterprises. There means a lot of companies, industries, and there is really a good example in which kind of connection could be among the research and industries. My question is, for ESFRI, for instance, are you just thinking about to have some way to support this kind of system, this kind of connection, and how can just improve that also in other fields, for instance? And I would like just to know that ESFRI in general is thinking about to give support to this kind of network among research and industries and companies. Thank you.
So very much in relation to this outreach and being able to engage for promotion. Yep. Carlo, please.
Yes, no, there is one point that came in the presentation on ESRF, and definitely was not when I was involved in writing the statutes of ESRF. The point is, what you were saying, we know, and most large research infrastructures know, where is the knowledge of the users. Now, one thing, the model that is normally applied in this kind of infrastructures is that the user accesses the infrastructure for free and pays by publishing the results. Now, I am wondering whether we should extend this approach to the fact that the users and their knowledge can be publicized by the research infrastructure to the industries or other institutions that need to access knowledge. Because publication per se is not enough. So you have to have an active role in putting the users who have been engaged and they have been provided for free the access, also with the commitment to respond to questions by external entities or also users. So you have the users of the users. So now I am afraid that this contrasts a bit with the rules on confidentiality, most probably. I don't know whether we can publish the user lists, but probably there is something that should be thought also at European level, how to make the research infrastructures exchange places between potential users of the knowledge of the users. So I think that this could be an interesting point of evolution in the way the business plan is made.
Actually, that's already implemented. We've had approved this by our council a few years ago, and I've personally developed a big software package that's actually doing that. So you can actually go and search in all the experiments that have been done at the ESRF, not at the ones that were refused, because this is still IP from the person who actually proposed the experiment. This is off limits because it's not done and hasn't been funded. The funded part you can search, and you can actually, there's a data policy now in place that all the data sets are open data together with the metadata and the notebook of the people who actually did the experiment.
That's easier.
Yeah, so this is already in place.
But should be probably made more general, because I don't think that it's well known as yet.
Okay, Thank you. I thought we were supposed to be finishing at 2:30, and I was telling everybody to hurry up, but in actual fact, we've got plenty more time. So, my bad. Thank you for the... Just to turn it a bit, do we have any opinions, please, on the questions, not on the questions being asked, but rather on any responses, potential responses to any of the questions that we have here on our board, so that we can... It will help us go back with our response to the forum. Any, please. Thanks.
Thank you. My name is Eckhard Liegenthal from Federal Ministry of Education and Research in Germany. Harald Reichert, as you just mentioned, the research ex post and what has been done. What about the measures that enable or support cooperation with industry through a single point of entry for more than one photon source or light source, whatever kind? Because I think, I mean, I know you have the brightest light in Europe, but probably some industrial problems don't need that type of source and could easier be done at a smaller source or done in a different way with neutrons or whatever. Is there any, measure to give such a chance for especially non-scientific users, or they're not users yet, potential users?
Harald, I want to, and just on top of that question, have you got any business development managers in ESRF?
Yes, I was actually very successful.
Good.
He's actually here. He's here.
Yeah, this is the thing that sort of is lacking, I notice.
We have a business development office.
Business development man.
Yeah.
Please, sorry, in relation to Eckhardt's question, do you have any response?
This is a bit more tricky because the reason is that the funding model behind each of these facilities is different. So if you actually start collecting this, let's say, in a central place and then distributing it, that goes against what our funding agencies say. So this would actually be a problem that first has to be solved on the funders level.
I've heard this before.
I mean, technically, it's, I think, not that hard to implement, but we would need the agreement of the funders to actually do that.
There's a difference between national and consortium level. I've heard this.
Well, if you look in the website of Erik, we do exactly what you are suggesting. We have medium-sized research facilities in material science, offering a number of different probes, from electrons to neutrons to ions and photons, and they can be used by industry because they are not top of the notch, but they are standardized. So if you look at it, there is one research infrastructure that is developing this.
Over here. No, it's this gentleman first, and then back to you, Robert.
Thanks. Yeah. Magnus Fredriksson, one of the panelists. I'm guilty of charge for this Ferrari thing. I was just really glad that the gentleman over there brought up this. This is what we do right now. We try to build up this industrial portal for industry issues because we know we have a lot of really nice facilities, but we have industry problems, issues, challenges. And you're right, sometimes we only need a SEM, sometimes a synchrotron, and sometimes just a meter. But we, as an industry, we have a question and we're searching for an answer. And we can utilize the synchrotrons or a research facility by proprietary beam time. It means by cash. And if you look at the statistics today, Harald, maybe you can correct me, but in general, 70 to 80% of all B time at the facilities is made by academics. 20 to 30% is academics in collaboration with some industry. And this is shocking. Some facility, lower than 1% is proprietary beam time. Beam time that is bought by the industry. So then we go back to the need of the industry. When we engage the industry to pay for the beam time, you will not be able to serve the industry. It's just looking into other things that happens in the past. Electric cars, for example, cell phones and so on. When the market see the benefits, it will come. So, and I'm quite convinced that this will happen soon in Europe.
Thank you. Robert, yeah.
I just wanted to comment on the question in the middle, because there's a lot of myths around this. How can use of existing RIs be increased, right? ESRF is full, Harald, right? So if you're going to increase the use of ESRF, then you either build more instruments, and so you need investment, or you diversify it. Usually they write increase, what they mean is diversify, right? Into different communities. You need investment to increase.
Actually, we have a reinvestment capacity, and the instruments are constantly upgraded. I'm not talking about the big upgrades where you replace the entire accelerator infrastructure. I'm talking about instrument upgrades, which is continuous and which is increasing the throughput, meaning we constantly increase our capacity.
And you are unusual because you have quite a good investment budget already in your budget.
Yeah.
But there's this other set of research infrastructures which basically are research infrastructures built up out of instruments which are partially used as a research infrastructure, they're partially private research. And there it's marginal costs, right? There's a lot of research infrastructures essentially where use could be increased significantly for marginal cost, not for real cost. And some of those have been created on that basis. But you've got to, not all research infrastructures are the same, right?
Actually, most of it is not investment, is in people. Because it's people operating the instrument. If you put more people there, you can actually speed up things enormously.
So it's not, yeah, it's not only all research infrastructures are different as well. Some research infrastructures are doing things much better than other research infrastructures also. And I think to your point about needing more people, this is where we've talked before, where I think the Commission can play. You look at the Marie Curie program. What's to say that we couldn't use the Marie Curie program to create this sort of web or suite of research operators to go around research facilities as knowledge sharing, knowledge transfer, to try and upskill and transfer knowledge? You're shaking your head, you don't agree with me on this. No, you see, huh?
Actually,
no, but it falls within the spirit of the program, and indeed it would assist with research infrastructures by creating this web of opportunity for research operators.
Jose Luis, I have a perfect example for you. A few years ago, we were luckily successful in one of these programs, and we got a PhD program for 40 PhD positions, joint between the ESRF and the ILL, where an academic and a company partner with a scientist at the large research facility. And we have 40 of these projects running right now. And they're incredibly successful. It was highly oversubscribed, and we got 40 companies with this into the facility, paired with an expert from the academic world and someone on the ground at the research infrastructure. And the PhD students spend time in each one of those facilities, at the company, at the research lab in the university, and at the large-scale research infrastructure. So this is possible. And it was a one-off. I don't know if we managed to actually extend that into the future, but it's a stunning success. I think it was the first ever proposal like this, and it went through with 15 or 15 points, right? So you can actually do something like that, and I believe it's successful, and this is exactly how you get the knowledge out into the community.
Sorry, Harald, if I may, you said it would be ESRF and ILL. Did you say in cooperation with industry as well?
Yes.
Yeah.
So we put in the proposal jointly between ESRF and ILL, but each one of those 40 projects has an industrial partner, a company behind it, and we are doing their problem, not our problem. They actually bring the problem.
So the student is the glue between the industry partner and the facility.
Yes.
They're the conduit.
Yes.
Okay, we've got a few minutes left. Is there, Michaela, I guess you have a lot of stuff there. That's great, thank you so much. Is there anything, any other issues we'd like to raise? Any other questions, answers to the question, anything else for our panel? Please, Giorgio.
Thank you.
picking up some of the ideas on how to operate more jointly or exploit better the synergies among research infrastructure in order to produce more and better science. We have consolidated the experience of what we call a technical liaison network among all the participants to the NFFA infrastructure. And what it is, it's scientists or technologists operating at the facilities, doing their normal job, but dedicating a consistent amount of time in a dialogue with all the correspondent colleagues at the other facilities. This is a ready-to-react system for a new proposal that comes in and that has some complexity so that it can be addressed by different methods at different, possibly at different locations, often in different locations. And so there is a feasibility and sometimes a suggestion of improvement of the proposal in the dialogue, pre-submission dialogue with the users, and then an optimization of the access, because of course you don't want to multiply uselessly the missions, but you want to do the right thing. This operation, which is advantageous, it has some complexity, but it can run very smoothly and has clear advantages for the users, has a big added value for the participating laboratories because they have an automatic positioning with respect to the full landscape of the other institutions. And if you start having 20 or 30 institutions, it's a significant benchmarking. It may drive to coherence in the individual upgrade programs of the different institutions. So different institutions with their own budgets, their own models and everything are led not to duplicate, but to be more excellent investing in one thing, the colleagues in another thing, and overall the European landscape gets richer, more efficient, and offers a better service to the users. So this can be done. There are experiences. Of course, I think it's a principle and it's an operational model that may be one of the elements for the general evolution of the research infrastructure systems in Europe.
Thank you, Giorgio. Anything burning? Or should we leave it at that? Okay, well, I think that just leaves me to say, well, thanks to all of you for your excellent participation. It's a great debate, and particularly to our four panelists for taking the time to put together your presentations. Thank you very much and putting so much effort into this. Thank you all.